Let's do homework exercise number 10 from section 8.3. Exercise number 10 states that you are borrowing amount P at a given value, and the loan's future value at a given time T. Determine the loan's simple interest rate. Okay, so this problem involves the loan's future value. So we're going to use the future value formula, which is A equals P times, in parentheses, 1 plus R times T. Okay, substituting the values you're given. The future value is $9,760. The principal is $8,000. Excuse me, times left paren 1 plus R, the rate we're trying to find, we don't know, so we'll call it R, and then the amount of time is 4 years. Okay, now this is where you have to apply, you have to distribute the 8,000 on the right side. So copy down the left side. 8,000 times 1 is simply 8,000. 8,000 times 4 is, you can do it on your calculator, 32,000 with times R. You still got the R. And then we're going to go ahead and solve for R. We're adding 8,000, so we're going to subtract 8,000 from both sides. And we're going to get $1,760 is equal to 32,000 times R. If we divide by 32,000, we'll get 1 R, which gives us R. So I'm sorry here, this would be divide both sides by 32,000. So that means R is going to be the 1760 divided by 32,000 and then multiply by 100 to get it in terms of a percent. So again, you've got to do a couple algebra steps. You've got to distribute the 8,000 times 1 and the 8,000 times R times 4. 4 times 8,000 is 32,000. You can do it on your calculator. And then subtract 8,000 and divide by 32,000. So we get 1760 divided by 32,000. We'll do that on our calculator. And then multiply by 100 to turn it into a percent. 1,760 divided by 32, I think I said 32,000, not 3,200. 32,000. Multiply by 100, or move it over 2 decimal places, and we get 5.5%. All right, let's look at problem number 11. Principal is borrowed and the loan's future value at a given time. Determine the loan's simple interest. Okay, again, we're going to find his simple interest rate. Future value is involved, so the formula is A equals P times 1 plus RT. Future value is $2,863. The original principal is $2,800. 1 plus the rate we don't know, so we'll leave it as a variable R. And time is 3 months, so it's going to be 3 divided by 12. Okay, so we're going to distribute the 2,800 times 1. 2,800 times 1 is 2,800 plus 2,800 times 3/12. So we'll do that on our calculator. 2,800 times 3/12 is 700. So now, what do we have? We have 2,863 equals 2,800. Distribute the 2,800 times 1, and then 2,800 times the 3/12 is 700 times the R, because we had the R there. So now we're going to subtract 2,800 from both sides and get 63 equals 700 R and divide by 700. Again, previous to this, we had 2,863 equals 2,800 times 1 plus R times T, which is 3/12. And when we distributed a 2,800, we got 2,800 plus 2,800 times 3/12 is the 700R. That's where I got that right there. So then we subtract 2,800 from both sides to get cancel out, divide by 700. So R is going to equal 63 divided by 700, and then we're going to multiply by 100 to turn it into a percent, or move it 2 places over. So we'll do that on our calculator. 63 divided by 700 times 100, and we get a 9% rate. Let's look at problem number 12. You're given the present, how much present value P must you invest in order to have a future value A at a simple interest rate after time T. So this time we're missing we're missing P, right? We're given A, R, and T again. Future value is A equals P times 1 plus RT. There's the formula. Substitute in what's given. A is 8,500. P is missing, so we'll leave the variable P in. 1 plus the rate, 4% as a decimal is 0.04, and times 6, because it's 6 years. Okay? Now what you can do is you can get one value for this. You can simply multiply 6 times 0.04, which if you do it on your calculator, you'll get 0.24 and add 1. So you get 8,500 equals this number right here will be 1.24 times P. Okay, you can simply do 1 plus 0.04 times 6 on your calculator. 6 times 0.04 is 0.24. So then I did it in my head. And now to solve for P, 1.24 is times P. So you divide both sides by 1.24. Here, the 1.24 to divide by 1.24 is 1P. So P will equal the value 8,500 divided by 1.24. So let's do that on our calculator. 8,500 divided by 1.24. Now, it says round up to the nearest cent. Okay, so cent is hundreds, 2 decimal places. So 6,854.838. There's cents, hundreds. Following the 3 is an 8, so we'd round up 6,854.84. Now, even if this number was only a less than 8, like a 4 or 3, 2, 1, it says round up. So even if this number was smaller, the answer would still be 6,854.84 because it says round up, not to the nearest. So you got to be careful. You got to see that word up. Okay, so $6,854.84. All right, let's look at problem number 13. Again, we got to determine P. We're given A, R, and T. And remember, we got to round up our final answer. So formula is A equals P times 1 plus RT. Substitute in what we're given. A is 8,000. P we're missing, so we'll leave it as a variable P. 1 plus the rate. 13.5 as a decimal is 0.135. And the number of months is 9/12. So now again, this is going to be this right here. We can multiply, we can take 1 plus 0.135 times 9 divided by 12 and get one number. So we'll do that on our calculator to get one number. So we'll take on our calculator 1 plus 0.135 times the amount of time, which was 9 divided by 12, and we get 1.10125. So now remember, what did we have? We had the amount was 8,000, equals P times 1 plus 0.135 times 9/12. But this 1 plus 0.135 times 9/12 is right there, right? So now we have 8,000 equals 1.10125 times P. To solve for P, we'll divide both sides by 1.10125. So that reduces, so you get P is going to be 8,000 divided by 1.10125. So we can do that on our calculator. $8,000 divided by 1.10125. And again, now, here's where you got to be careful. Round up. Very easy to make a careless mistake. Notice the word round up. So 7264.472 to the nearest cent hundredths. So even though there's a 2 there, if it was normally, we would just leave it a 7, but because of the word up, we're going to go up to an 8 automatically. 70, so it'd be $7,264.48. Again, be careful because of the word rounding up. We automatically add 1 penny, even though normally with a 2 we would keep it a 7. All right, so that indeed is our final correct answer. Let's put it in the $7,264.48. All right, we're going to stop this session here. If you have any questions, send me an email at tswierzz, tswierzz@hodges.edu, or call me at 239-938-7805. Thank you.